Hello everyone. So kule video sizodiscussa a question from number patterns from a question paper laga November 2011. So sizocala question 2 no question 3, right? So yeah, ngaphandle kokuthi simoshe isikhathi asivele sithome lapha ku question 2. Okay, ngizotoma ukwenza u2.1. Let me just copy this question and then see later go whiteboard here too. Okay, so okay, so what is given the sequence for x32, determine the value of values of x if the sequence is arithmetic and if the sequence is geometric. So sizotoma ngaleya 2.1.1. So if the sequence is arithmetic, it means that we have a common difference, right? So the difference between term 2 and term 1 is x minus 4. The difference between term 3 and term 2 is 32 minus x. So if this is a geometric an arithmetic sequence, it means that we have a common difference, which means that x minus 4 is equals to 32 minus x, right? So now solving for x, we see that taking x to this minus x to this side will have 2x, and then taking 4 to the other side will have 36. Therefore x is equals to 18. Okay, right, so that's 2.2.1. 2.1.2. If this is a geometric sequence now for x32, if this is a geometric sequence, if this is a geometric sequence, then term 2 divided by term 1 is equals to term 3 divided by term 2, because we have a common ratio there. What is term 2? Term 2 is x. Term 2 is x. Term 1 is 4. Term 3 is 32. Term 2 is x. So yeah, now we just solving for x. Now cross multiply, so the x squared is equals to 128. Therefore x is equals to plus or minus the square root of 128. An easy 5 marks there. Okay, moving on to the next question. So question 2.2, let's copy 2.2 to our whiteboard. Okay, then create a space ilana for 2.2. So Lagu 2.2, but it determine the value of p if p is equals to this sigma notation here. So you are given a sigma notation. Sigma means we are summing, né? This sign means we are adding. So we have p equals to this addition, right? Let us sort of break down this. So p is equals to the summation from k equals to 1 to k is equals to 13 of 3 to the power k minus 5. Now we break it down. It means that starting at k equals to 1, so no 3 to the power 1 minus 5, so that is 3 to the power minus 4, plus now we are at k equals to 2. Now to 3 is equal 3 to the power 2 minus 5, that's 3 to the power minus 3, right? Now we're at 3 when k is 3 is over no 3 to the power 3 minus 5, which is 3 to the power minus 2, right? And then now we are at 4 k. When k is 4 is over no 3 to the power 4 minus 5, which is 3 to the power minus 1. Now we are at k is equals to 5, so 0 3 to the power 5 minus 5, so 0 3 to the power 0 there, and then all the way to when k is 13. So when k is 13 is over no 3 to the power 13 minus 5, which is just 3 to the power 8 there. So now when we simplify this, 3 to the power minus 4 is the same as saying 1 over 3 to the power 4. There will 3 to the power 1 over 3 to the power 3 plus 1 over 3 to the power 2 plus 1 over 3 to the power 0 is 1 plus all the way to 3 to the power 8. Okay? So now we have a series. We have a series. If you look at this series, it is a geometric series because to move on to each term, we are multiplying by 3, right? So therefore, we have a geometric series with the common ratio r equals to 3, and the first term is 1 over 3 to the power 4 or 1 over 81, which means that a is equals to 1 over 81, right? So in other words, p is equals to a geometric series, right? Now when we are summing these terms of the geometric series, we'll get the value of p. So because r is greater than 1, we will use this formula for a geometric series, Rn minus 1, r minus 1. So p is equals to S13, which is equals to 1 over 81 times 3 to the power 13 minus 1 divided by 3 minus 1. So this is equals to now press our calculator yakho uzothola ukuthi this is equals to 9,841.49. so therefore p is equals to that number. So yeah, that is the value of p, this one here. Okay, now moving on to the next question, 2.3. It's a proof. So let's copy 2.3. It's a proof. Okay, so 2.3 is a proof, but prove that for any arithmetic sequence of which the first term is a, and the constant difference is d, the sum of n terms can be expressed by that formula there. So they want us to prove that for an arithmetic sequence, when we are adding all the terms, we will get to this formula, right? Remember that the formula of the general term of an arithmetic is Tn is equals to a plus n minus 1 d, né? and then when you are adding the terms, you will have Sn is equals to T1 plus T2 plus T3 plus all the way to Tn minus 1 plus Tn, right? So now, therefore, substituting in that formula, you will see Uti substituting in that formula, using that formula T1, when you substitute 1 where you see n in that formula, you will have a. When you substitute 2 in that formula where you see n, you will have a plus d, jalo njalo. So from the formula of the general term, Sn is equals to a plus d plus a plus 2d up until you get to a plus n minus 2d plus a plus n minus 1 d, since this is just the formula of the general term, right? And then we will call this our equation 1. We will call this our equation 1, right? Now, writing the same equation in reverse order, you will have a plus n minus 1 d plus a plus, so we are writing this equation in reverse order, a plus n minus 2 d plus all the way to a plus 2d a plus d plus a, right? And then we will call this our equation 2, right? Now add equation 1 and equation 2, right? So when you add equation 1 and equation 2, you will have on the left hand side, you will have s plus sn plus sn will be 2sn, right? Now we will have a plus a, which is 2a plus, and then you'll see Lana, if you add a plus d, wait, so it's gonna be, so it's a plus a is 2a, and then plus n minus 1 times d, so that will be n minus 1 times d, right? It's also the same when you're adding a plus a, you'll have 2a plus n minus 2d plus a plus d I mean. So we added a and a, we have 2a. Now we're adding n minus 2d plus d, it will give us n minus 1d, right? Because if you say a plus n minus 2d, this is this, from this ne into is this one, this bracket here, and then plus this bracket here. It's a plus d, right? So we collect like terms. A plus a is 2a, and then plus, now when you factorize d from this other one, you'll have d, okay, you'll have, as multiply out to d, now you'll have nd minus 2d plus d, right? So you'll have 2a plus nd minus d. Now when you factorize d, uzoba no 2a plus n minus 1 d. So into eyenzekako ngileyo when we are adding equation 1 and equation 2, right? When you carry on the same way, we add equation 1 or equation 2, when you are adding the corresponding terms are equation 1 or equation 2, all of them are equals to 2a plus n minus 1 d, right? And then since we have n terms that we are adding, we will have this bracket n added n times. So sizoba no 2sn is equals to n times this bracket 2a plus n minus 1 d, right? Therefore Sn is equals to n over 2a plus n minus 1 d. Okay, yeah, so it's totally 4 marks yakho by knowing the proof yaga Sn. Now moving on to question 3. Okay, question 3. Okay, let's copy question 3 there. Let's copy the first 2 questions of question 3. We'll come back to the last one. Okay, so we have question 3, but the following sequence is a combination of an arithmetic and geometric sequence. Write down the value of the next 2 terms. Okay, so 3.1, from that sequence they want us to write the value of the next 2 terms. So 3.1 the original sequence is 3, 3, 9, 6, 15, 12. They want us to write the next 2 terms, right? So here we have T1, we have T2, we have T3, we have T4, we have T5, we have T5, we have T6. So they want us to write T7 and T8. Ne? They want T7 and T8. So, but this sequence is a combination of an arithmetic and geometric. Ne? So, okay, it's a combination of an arithmetic and a geometric. So, which parts of the sequence form an arithmetic sequence and which terms of the sequence form an arithmetic sequence and which terms of the sequence form a geometric. So if you look at term 1, term 2, term 3, term 5, those terms form an arithmetic sequence, because to move from term 1 to term 3, they added 6. To move from term 3 to term 5, they added 6 again. They added 6. Right? 3 plus 6 is 9. 9 plus 6 is 15. So to move from term 5 to term 7, you must add 6, and then you'll get to 21. Right? So jalo jalo. So notice ukuthi the odd terms in this sequence are the arithmetic terms, are the terms that form an arithmetic sequence. So term 1, term 3, term 5, term 7 form an arithmetic sequence, right? Which means the remaining terms form a geometric sequence. So the remaining terms are so T7 is equals to 21. T7 is equals to 21. Right? So the remaining terms should be the geometric ones. Right? So when you look at term 2, term 4, and term 6, those terms form a geometric sequence. To move from term 2 to term 4, that is to move from 3 to 6, they multiplied by 2. And then to move from 6 to 12, they multiplied by 2 again. Also, to move from term 6 to term 8, you will multiply by 2. So there you'll have 24. When you multiply 12 by 2, you'll get to 24. Therefore, term 8 is equals to 24. Okay, so now they want us to calculate. That is question 3.1. Okay, so question 3.1. Question 3.1. So question 3.1, term 7 is equals to 21, term 8 is equals to 24. Okay, so question 3.2, but calculate T52 minus T51. So notice ukuthi term in this sequence, the odd terms form an arithmetic sequence, and then the even terms form a geometric sequence. So the odd terms are so the odd terms is 3, 9, 15, right? So the odd terms are this one, T1, T3, and T5. They form an arithmetic sequence, right? And then we want to know the value of T51. T51 is an arithmetic term, is a term of the arithmetic sequence, right? So now T1 okay, so into kumele siyenze now, this one is a tricky one, ne? Into kumele siyenze ukuthi from this original sequence sithole ivalue yaka T51 nevalue yaka T52, right? So when you take out T51 is a term of the arithmetic sequence in this original sequence, right? Because the odd terms form an arithmetic sequence and the even terms form a geometric sequence. So extract the terms that form an arithmetic sequence from the original sequence. So from the original sequence, take out the terms that form the arithmetic sequence. So now lana ama terms lawo. So the common difference is we have the first term is 3, the common difference is 6, right? Therefore, when you write the formula for Tn, you'll see that this is this is what Tn is equals to 3 plus n minus 1 d, right? So Tn is equals to 6n minus 6 plus 3. So Tn is equals to 6n plus 3, right? So now no, I made a mistake. Tn is equals to 6n minus 3, because it's 6n then minus 6 plus 3, that's 6n minus 3, right? So now into kumele siyenze ukuthi sithole ukuthi uT51 term number ngakhi in this arithmetic sequence. Into ngishoko la ngithi uT51 in the original sequence term number ngakhi in this arithmetic sequence, right? T51 is a term of that original sequence. So ngifuna usazi ukuthi uT51 term number ngakhi in this arithmetic sequence. So ukuthi sithole lokho, notice ukuthi ama position wale arithmetic sequence is ama position wama terms of the arithmetic sequence in that original sequence. So nasiya ku position 1 sizothola ukuthi we have a term of the arithmetic sequence. Nasiya ku position 3 sine term arithmetic sequence, and then masiya ku position 5 sine term arithmetic sequence, and then again position 51 term arithmetic sequence. No, term 51 term ilokanje, term 51 term arithmetic sequence, but then we don't know its position, right? So into ngifuna ukuyenza ukuthi ngithole iposition yaka T51, ukuthi uT51 ukuposition bani in this arithmetic sequence. So ukuthi ngenze lokho, notice ukuthi ama position lawa they form an arithmetic sequence now, so with a common difference of 2, and then the first term is 1, the common difference is 2. So ama term lawo you'll have their general the formula for their general terms as Tn is equals to 1 plus n minus 1d times 2. So it will be equals to 2n minus 1, right? Sifuna ukuthola ukuthi term 51 ukuposition bani in this sequence, right? Term 51 ukuposition bani in our sequence. So ukuthi sithole lokho, okay, we want to know the term 51 ukuposition bani in our original sequence. Sorry, I think angayichazi kuhle. So I think into engifuna ukuyisho ukuthi okay, ama position lawa wala ma terms aku arithmetic sequence from the original sequence, the odd positions 1, 3, 5, 51, the odd positions, it's where we get the arithmetic sequence, right? So notice ukuthi if you take the positions la esithola khona the arithmetic sequence and write them down here njengoba ngenzile ngithi 1 ku position 1 we have a term of the arithmetic sequence, ku position 3 we have a term of the arithmetic sequence, and then now position 5 njalo njalo. And then when you write them down, you will notice ukuthi now they form a sequence, right? So this is the sequence. Ngifuna ukuthola ukuthi this one iku position bani in the arithmetic sequence. Siyazi ukuthi it's term 51 ku original sequence. So ngifuna ukuthola ukuthi term 51 ku the original sequence u term number ngakhi in the arithmetic sequence. So lana ngizothi substitute 51 there, and then solve for n. Uzokuthola ukuthi n is equals to 52 over 2. So n is equals to 26. So in the original sequence, term 51 is term number 26 in the arithmetic sequence, right? Hey, I hope it makes sense because I know this one is a tricky one. So term 51 is term number 26. Term 51 in the original sequence, term 51 in the whole sequence is term 26 in the arithmetic sequence. Yeah, icabange njalo. So nangifuna term 51 ku the original sequence, ngizo substitute u26 ku arithmetic sequence. So T51, oops, so ngithi T51 in the original sequence is term 26 in the arithmetic sequence, right? So T51 will be equals to term number 26. Okay, let's calculate term number 26 from the arithmetic sequence, because last is okay. Term number 26 in the arithmetic sequence is term number 26 in the arithmetic sequence is 6 times 26 minus 3, that is 153. So in the arithmetic sequence, term 26 is 153. Therefore, T51 in the original sequence is equals to 153, right? And then now siyaku geometric sequence. Term with geometric sequence are these ones. It's 3, it's 6, it's 12, all the way to term number 52, right? And then to get the value of term number 52, let us get the the same story applies with the geometric sequence. Term number 52 will be term number 26 in the geometric sequence. So in the geometric sequence, we have the first term is 3 and the common ratio is 2. So Tn will be 3 times 2 to the power n minus 1. So to get term number 52 in the original sequence, we'll have to get term number 26 in this geometric sequence, right? That is equals to when you substitute this in your calculator, you'll get that it's It's 100,663,296, right? Therefore T52 is equals to this number. Now when you take the difference between T52 and T51, you'll get that it's this number minus 153. You'll get that the difference is this number here, 143. Yeah, this question is like kube nzima ukuthi ngichaze. Okay, I hope it makes sense ngendlela engichaze ngayo. If maybe it's a confuser, ungazise ngizama ukuyichaza ngcono. Yeah, it's a tricky one. Okay, so now we go to 3.3. Now we go to 3.3. Okay, nasiya ku 3.3 bathini lapha, bathini. Okay, let me just copy 3.3 to our board. All right, so 3.3, but to prove that all the terms in the infinite sequence will be divisible by 3. So for the arithmetic terms, so we go 3.3 for the arithmetic terms. For the arithmetic terms, Tn is equals to 6n minus 3. It's equals to 6n minus 3, right? So if you take this and divide by 3, you'll get that it's 1 over 3, 6n minus 3. It's equals to 2n minus 1. Therefore the arithmetic terms are multiples of 3, right? The arithmetic terms are multiples of 3, therefore they are divisible by 3. Otherwise, if they were not multiples of 3, we would get a remainder somehow. We won't get like a whole number when we were dividing Tn by 3, right? And then for the geometric terms, sithe formula yaga Tn is equals to 3 times 2 to the power n minus 1. Now when you divide this by 3, you will see what it's 2 to the power n minus 1. Okay, when you divide this by 3, so 1 over 3, so this one will cancel that one and uzosala no 2 to the power n minus 1. So in the geometric terms, each term is multiplied by 3 and a power n2 to n2 raised to a power. Each term is multiplied by 3 and raised to a power of 2. Yeah. Yeah, question 3 nangimrata ngasho ukuthi question 3 is tricky and kungaba nzima ukuthi enze sense. Nami nangichaza kwangazi ukuthi ngimchaze njani. But then nama sequences like ama question njengalawa, try to sort of think outside the box. Cabanga these sequences ngendlela man uzama ukuvisualize what's happening, because zama uphendula ama-answer wakho in a way that makes sense to you. Mhlambe ngiyibeke njalo. Yeah, like for this question u-3.2 ama-approaches wa this one angaba maningi, but then egcineni kumele sifike ku-answer A1. Yeah, okay, that is enough for this video. Yeah, until the next one.